Alright, sorry, I'm just going to quickly move over my PWE file because I deleted it last time. I haven't moved it back, so I'm just taking a second to more or less put it back so I can do stuff with it. Alright, so I'm still going to be more or less just playing around. More or less just playing around. Let me change that. See that right here? Here's an example of being able to move something. Right. So I've made my file name a little bit wrong. So I have FS instead of FAS. So I'm going to correct that by using my move command and renaming this. Because you'll find out that typing is pretty tricky, and you're very likely to make a mistake. But you can always, like, the nice thing about Linux is you can correct any mistake that you want to. Even if it goes as far back as reinstalling the OS, you can always correct a mistake. Anyways. Okay. Alright, so now I have my PWE FASTA file back, and I'm ready to explore with it, play with it, and do some stuff with it. And so I'm going to teach another command. That's a grep command. And grep is really handy. So this is getting into a little bit more, I would say, intermediate level Linuxing things, right? Moving, copying, moving around the OS, listing contents, whatever. That's like the basic requirements to getting stuff done in Linux or any OS. But right, we don't really get to use our mouse in this environment. We really don't get to use like graphical tools to help us look at stuff. So we kind of have to get a little creative. And so grep is a creative tool that lets us look at parts of a file. So cat is looking for the whole file. Head is looking at the first few lines. But with grep, this can be synonymous with grab, right? So if I want to only look at a specific part of a file, I can use grep. And so grep, again, is kind of equivalent to like grabbing something out of a file. For example, if I cat this file, all I really see are sequences. But I know there are FASTA headers in here. And all of these FASTA headers, right, they start with an open caret. Right, just an inherent property of FASTA files. They all start with a caret. So I can just look at specifically just the headers of any FASTA file by using grep. So if I want to use grep, I'm going to use it, and this isn't literal. This is just an example, and then I'll move to a literal example. But say grep character file name. Right, that's kind of a metaphorical use of grep, or not a literal use of grep. But I'm looking for a specific character in a file. I can grep that character out. And so what grep is going to do is going to print all lines that have that specific character. And it can be a string. It can be multiple characters. But if I'm using this in a literal sense, I can do grep on the open caret. And recognize, whenever I'm grepping, recognize this open caret as a special character. We haven't talked about this yet, but this is another special character, like the tilde or an asterisk or the backslash. Open caret is a special character. So if I grep without quoting it, I'm going to run into some problems. So for special characters, they kind of have to be quoted. Sometimes they have to be escaped. But nonetheless, if I'm grepping on this character, what a crap sequence. My file's not right. I only have 2 sequences in my file. That's definitely not what's supposed to happen. So something is wrong with my FASTA file that I need to kind of fix kind of quickly. right? And again, like grep, without having to look at this entire file, I know that something is wrong with my file just by creatively using grep. So let me fix this one more time. Hopefully this will work. Don't necessarily pay attention to what I'm doing right now. Okay. And let's see if that fixed my problem. Make sure I have all of the sequences that I want in my FASTA file. So let me run that grep command again. I'm just going to use my up arrow to get back to that old grep command, so I don't have to type it out again. And now it looks like I have all of the right PeeWee sequences that I care about. And so with grep, notice that I'm highlighting, like my character of interest gets highlighted in my grep command. And so I can grep on any character. For example, I can grep on the ENS of these ensemble sequences, and that might tell me how many ensemble specific sequences I have. Since ENS is not a special character, I don't have to put it in quotes. I can, but it won't complain if I do, right? So I can do it with, I can do it with or without quotes, and it's not a problem. It's the same thing. But recognize now I'm not grepping out all individual sequences or all individual headers. I'm only grepping out the headers that start with ENS, or really any line that starts with ENS. So I have one additional sequence from the NCBI that we really haven't talked about, and the rest are from Ensemble. But yeah, grep is really, really super handy to mess around with. Especially like when your file sizes get impossibly large to look at. Like if we do look at genome files or giant CDS files, I can't remember if I downloaded, I might have removed it, but I can grep on that special character. I can grep on the caret and count sequences. I'm kind of just writing down kind of offhand, just kind of reminding myself of what commands I've mentioned, and also special characters so I don't mention them again. All right, one more example of using grep, because with grep, not only can I just print contents of a file, I can count them by using a specific option. Let's see how terrible the grep help looks like. Let's see if I can pull it out. Yeah. There's a lot of commands, a lot of options, I should say, linked to grep. But if there's one that's really, really common, it's the -C option. So with -C, instead of printing the lines that have the string I'm looking for, I can count the number of lines that have that character. So let's look at an example of using grep -C. So that's grepping on the open caret. Those are my sequence headers, but that doesn't tell me how many are present. So I can use the grep -C for that character, and again it's going to count the number of lines that has this special character, and it's 9 lines. So I have 9. I know by just grepping on the open caret, I know I have 9 sequences in this FASTA file. Now, as I mentioned, this open caret is a special character. Now, I have not used this special character, but I'm about to use this special character. Just as a simple example. So, this special character, this open caret by itself, what it means is save print output to a file. Right? That's what it really means. It lets us save printed text. Now this isn't something that I regularly do, or this example isn't necessarily something that I would regularly do, but we'll demonstrate the difference between this open char as a text and this open char as a command, right? It's almost a command. There's a better definition to it, but let's just observe this as an example. So I'm going to run this command that I've already run before, grepping out this open char, and so it prints my stuff to the screen. But I can push that output. I can save that output as a file name by using my open char. So I can use my plain open char and say headers.txt. And so what it's going to do is, instead of printing these lines out, these grepped lines out, it's going to save them to this file that I am now naming headers.txt. Right? So nothing got printed to the screen whenever I ran that command. But I now have a new file called headers.txt. And if I want to look at the contents of header.txt, I can cat that file, headers.txt, and there's all of my grepped output. Very, very nice and handy way of just saving sequence information, or saving my headers to a separate file. And sometimes I have to do that. It's not very common, but yeah, sometimes I will do this. All right, and so that will get handy in a minute. That will get more handy in a minute. So I'm going to get rid of this headers. I'm going to use my rm to get rid of my headers text because I don't really need it. And so this will be the first time that we actually run a bioinformatics specific command. So right, all of the software that we use is publicly available. All the software we use is publicly available. However, that doesn't mean it's installed on every single computer, right? Just like your computer, you have a default state and you can install software as needed. Same thing that happens in Linux. It's just all of that software is really only text specific. You can't, there's no buttons, there's no graphics, it's just running the text. And so kind of the first bioinformatics software that we've been introduced to, or that I introduced y'all to, is Muscle. Right, Muscle is a very common, very popular sequence aligner. Well, there is a Linux version of Muscle as well. So that command is just Muscle. And like most commands, now this is not a Linux specific command, so the help menu is going to be a little bit different. But it should still have a help menu. We'll see, as it still has a help menu. And so Muscle is one of the more polite sequencing or bioinformatic tools. Again, we're just using it because it's a nice example. We've used it before in a graphical context. We've aligned sequences in a graphical context. Now we're just going to align them without actually looking at our output. And so again, Muscle has this nice basic usage. And so you'll see in programs, I hate that programmers do this. I hate that this is the syntax because it's super complex, it's super annoying to explain, and you'll still do some weird things with it. But it's putting these not literal statements in our carets. So input file is not a literal statement, and we never actually put these carets around the input file name. It's just nomenclature, it's just syntax of what nerd writers do to say this is where you would put your input file. And this is where you would put your output file, but these are not literal statements. God, please do not put carets around your file names. Somebody's going to do it. I'm going to call you out when you do it, but please don't put your carets around file names. So again, this is not literal. It will not work. It's just going to complain, and you might even break something. Anyways, so musl. If you notice in this help menu, what is not literal or what is literal are our options, right? So options are never, they're always literal. So it's going to be a dash in and a dash out. Those options are necessary. Those are literal. You have to have them present. Because musl demands this. Not every program demands this, but musl, the writers of musl made this as a demand. But we have additional options, so in and out are required, but we can still change other properties about musl that we are not necessarily going to touch, because if you don't know what you're doing, don't touch it, just go with default. But notice, if I'm running this command literally, it's going to be musl-in, and then my input file name, and that's going to be my PWE FASTA file, and then an output file. That's whatever I want it to be. So I might say pwe.aln.fast, because the output will still be a FASTA file. And whenever I hit that command, it's just going to say it's running. It's popping up some output that says that it is running. It's on the 4th iteration, and now it's done because this is a small file. Musl doesn't take very long on a nice small file. But now I should have two files present, my raw FASTA file and my align file. And so I can go ahead, I'm just going to go ahead and look in my alignment file, and I see the gaps present, right? I know that this is aligned because I have gaps present in my FASTA. And so I can just scroll through here. Let's see how many gaps. I got a 5 gap. Yep. So I'm gonna get here in a second. But notice this is an okay alignment. It's fine. Running musl. Control Z to exit, so I don't have to look at that all the time. Okay. Now musl is a little limited. It's kind of limited. It's limited because it cannot natively do a codon alignment. It can natively do a amino acid alignment, and it can natively do a DNA alignment, but it cannot inherently do a codon alignment. And we find other good aligners have the same limitation. If you want musl to do a codon alignment and you want to do it on a server, you have to work around that problem. We're not quite ready to work around that problem just yet, so we'll leave it at this point for now. But let's see. I think if I don't provide an output file on this, I think it will just complain. Nope, it's still gonna run. Let's see what happens. All right, I printed it to screen. So the default state for musl is to print the output file to the screen. So at this point, it's not saved. If we see a whole bunch of text spitted to the screen, it's not saved. It's not going to be saved. It's just printed and lost. Right? Let me demonstrate this one more time by removing the PWE align. Okay, and I'll run that same command. I'm just getting curious. I'm going to see if I don't need this in option. Nope, I do need an in option. For sure do need in. Don't need out. But I do. In is an absolute requirement. So again, let it run. Take a couple of seconds. Stuff gets printed to the screen, but I save absolutely none of that. Right? I don't have an alignment file. I did not write an alignment file because I did not give Mega an option to write stuff to a specific file. Common rookie mistake, to make an alignment but not actually save it. So some programs are built this way. Actually, a lot of programs are built this way, where the default is to just spit the output to the screen, because partially it's assumed that if you run Linux, you know about this OpenCaret. So I can use my OpenCaret. I can just provide my input file, use my output, my caret, to save the output text as a file name. So again, I can do pwe-align, and it's going to do all this stuff. It's going to reiterate all this stuff, do this program again, and then save. Right? Nothing got spitted to the screen. My alignment was not spit to the screen. It was saved to the file. And that's the beauty of the OpenCaret. And that's how that special character works. All right. Yeah. So, as I don't know if I mentioned before, but there are at least 12.5 different aligners. They're all okay. I would still argue that aligning is not a solved problem. We just have a pretty good solution to the problem, but it's not necessarily solved, right? And it's not solvable, right? Because things are unknown and things will stay unknown, and we can't fix the unknowns in an alignment, whatever. But nonetheless, some programs are actually kind of helpful given a specific situation. So right now we just have DNA sequences, and we can't do a codon alignment. At least some of the aligners can't do it natively. But one particular aligner called Prank does have the option to do a codon alignment. I kind of forgot how to use Prank, so I'm looking at the options again, looking at the manual. Yes, and so in this I need to, with my Prank command, see, right, with Prank I don't even need to describe an in option, right? It's just going to read in the first file that's given to it. But nonetheless, I have all of these other different options. And so with this, I should be able to, I swear I just saw it. Yeah, codon. So I can have this codon option. So if I give Prank this codon option, it will run a codon alignment for me. So it will inherently do what a codon alignment is, translate my DNA to amino acid, align my amino acids, and then more or less plot my DNA, my codons, on that amino acid scaffolding. Right? That's effectively what a codon alignment does. It gets rid of, it reads an alignment, translates to amino acid, aligns the amino acid, and then plots the DNA sequence against a scaffold, a amino acid scaffold. Very nice and handy. And as far as I'm aware, Prank is the only aligner that will do this natively. If you know of a aligner that can do this natively, that's not Prank, you know, leave me a comment. That's fine, because I honestly don't know. That's honestly a statement to the internet, not just y'all. Nonetheless, if I want to do a codon alignment, I'm going to call my Prank with my option for codon, and then so we should see. Let's get this help menu back out. We do kind of want this -d option. So -d is just going to save the sequence file, right? That's how I'm going to put in the sequence file. And this is probably literal, that I probably need this equal sign here present. Let's see, yeah. And so my output format is inherently going to be FASTA, but I can save it as others. Not worried about the other FASTA, formats. Probably not going to use them all that often. FASTA is by far the most common, so I usually keep things in FASTA format. But yeah, let's see how we can make this program work. So prank dash codon dash d equals, let's see, I'm just gonna not even include my d and just see what happens. POE test.fast. And let's just see what happens. Oh, it complained. It complained. And the most frustrating, some of the most frustrating crap about this is that it really won't tell you what you did wrong. It's just gonna say you did something wrong, but it really won't tell you. It might give you a clue, but no Linux program, no command line program anywhere is really going to tell you what went wrong, unfortunately. But all it's saying is as an unknown option. That's because I probably didn't do my -d option. So let's run that again with my -d. I'm not going to put the equal sign. Again, I'm just kind of playing around with it to see what's required. So I'm going to start with just having a -d, and it complained again. It's still saying doesn't know the option. Hopefully, let's see. Let's try one more time. -d equals. There we go. Now it's running. Huzzah! We got it. And so this will probably, I don't know how long this is going to take. If I recall, prank is a little bit slower than the others. And I don't think I can use additional processors. I think I'm only limited to one processor with prank. Other programs will let me use multiple processors and run much faster. Oh, this is going to take forever. It's not going to make me happy. Yeah. So, prank is okay. This is definitely one reason I don't like prank, because it's kind of slow. Another reason I really don't like prank is that it makes a very gappy alignment. And I don't like, and we tend to favor shorter alignments. Like bioinformaticians will usually argue that a shorter alignment is better than a long gappy alignment. And I think prank has a habit of making long gappy alignments. But again, if you want to use a better aligner, you have to build tools to basically do a codon alignment yourself, or at least have a tool that will translate, use your favorite aligner to build the amino acid, and then have another tool to lay the DNA down given the scaffolding of the amino acid alignment. Holy crap, this is taking way too long. It's taking way too long. So I'm not gonna let it sit there forever. This is just absurd. There's only 9 sequences. It's 1,000 bases. This is crazy. That's way too long. And so I just Control Z'd it to kill. I made a tempter. Nothing's in it. Get rid of that garbage. Um, 30. But let's see, one more time. Let me just look at the help menu one more time of prank. Output file, yeah, I can do a dash out, but by default it's just gonna put me. I think it's just gonna write a file called output. But yeah. Yeah. So I think if I were to run this, program literally and just waiting for it to finish, prank-codon-d equals peewee to help. There we go. And then a dash output file equals to let me know that this is a, sometimes like if we're doing this in best case scenario and you want your file name to be descriptive, I might do prank.codon.aln.fast. Yeah, and so that's going to take indefinitely to run. I'm not going to let it finish because it's going to take way too long for this to happen, but nonetheless, if you're in a more patient situation, you would just have to let this run until it finishes, unfortunately. And a dollar says whenever prank actually finishes, this temp directory that it makes will probably be deleted by prank when all is said and done, but here it's just going to stick around. So I'm going to get rid of it. Okay. Gosh, this might be a mistake. I might leave it at that for now. I think we'll pick up with other programs later. I would at least encourage you to, over the weekend, get to a point where you can get your whatever DNA file sequence you made. I forget what everybody has. I know everybody has made a different file or a different FASTA file for a specific gene. I would definitely encourage you to get that onto the server, do a muscle alignment, do a prank alignment, see how long it takes, and then we'll work on that file. We'll work on that output on Monday. But I think for today, I'm just going to call it there. That's already kind of a lot of stuff. You may want the FileZilla because you kind of have to have FileZilla to send stuff to the server. So it's a requirement. I haven't sent out a link. I'll send you a link. But no, you kind of have to have FileZilla to send stuff from your laptop over to the server of interest. If you haven't done that already. All right. Well, I'm gonna kill it, and I'll see y'all again on Monday.